Today's heading is forecasting weather. Forecasting weather. I'd like to put this down. You probably know it, I'm sure, but a meteorologist, a scientist who studies weather. When you watch the news, and they have meteorologist Jay Trobeck. Okay, he's a scientist that studies the weather. A couple other terms here. I'd like you to write down storm watches and those two bullets. If we are in a storm watch, there is the possibility of severe weather. The weather conditions outside are favorable for that severe weather. So if we are in a thunderstorm watch, that means there's not a thunderstorm going on, but everything, all the ingredients are out there for there to be one. So basically just like, hey, pay attention, this could happen. If we are in a tornado watch, it doesn't mean there is a tornado, but it means all the ingredients are there for a tornado. Just keep paying attention. Okay, or they have like a blizzard watch. Anything watch, it means just, hey, pay attention. Go ahead and write storm warning in just the first bullet. Storm warning, severe weather is in progress near you or coming toward you. So if you are in a thunderstorm warning, that means there is a thunderstorm happening currently, or there's a thunderstorm moving towards you. If you're in a tornado warning, there has been a tornado spotted and it is moving in your direction. Take cover now. So a watch is just, hey, it could happen, pay attention. A storm warning is take shelter, get ready, it's happening. You guys know isotherms, isobars. Isotherms shows temperature, isobars shows pressure. We won't worry too much about station models. I think you wrote down climate in the past. Weather is short-term, day-to-day. Climate is the average conditions over a long period of time. I thought this was kind of cool, the different climate maps. So like the purple here is tropical, subtropical. Well, we have rainforest there, we have some there. The orange and yellow is arid, which means it's dry, so kind of desertish. Green is temperate, which is kind of what we're in, meaning we get a kind of a mixture of everything. We get snow and cold winters, and we get hot, humid summers. So I don't know, something to look at. Here we go. Don't need to write anything, but there are a couple other factors that are going to affect weather, and those are coastal areas and mountains. We're going to start with coastal areas. I'd like you to write this down. Coastal areas have warmer winters and cooler summers. So let's say I live over here in Portland, okay? So this is Oregon, Washington, here's the Pacific Ocean. If you think about it, okay, if you took a line straight across here, usually the more northern you are, the colder it's going to be, right? Okay, well, Portland is more north than Rapid City. Portland, however, always has warmer weather in the winter than Rapid City, always. And the reason for that is because the water, okay? The ocean water takes a long time to change temperature, especially a large body of water like an ocean. So all summer, the Pacific Ocean heats up, okay? The sun is shining, it's warming up that water, warming it up, warming it up, warming it up, okay? Well, we get to winter, and this water is still pretty warm from the summer, okay? So that warm water is here, and then you're going to get winds that blow this way. Well, that wind is warmed up by the water, and so Portland here is going to get nice, pretty warm winds, okay, which is going to keep the temperature at a decent temperature, a warmer temperature over the winter. Rapid City doesn't get that because we're nowhere near a large body of water. On the other hand, in the summer, the ocean is still cold from all winter. Okay, it's still really cold from the winter. So let's say July, when it's really hot, and Rapid City might have 110 degrees or something like that. Portland might be at like 80, a nice temperature, because the water is still cold, and we're going to get breezes, ocean breezes, that are going to be cooler, that are going to keep Portland at a decent temperature. So that's how coastal areas have warmer winters, cooler summers. Mountains, and I put this down, mountains have a wet side and a dry side. So mountains affect the climate of an area because they have a wet side and a dry side. Okay, so let's say this is the Rocky Mountains here. Okay, we have these warm, wet clouds. Okay, just waiting to drop precipitation. Okay, well, these clouds want to move this way. Okay, well, as they move, clouds can't just go through the mountain. In order to go through, to go the other side of the mountain, they've got to go over the mountain. Well, when these warm, wet clouds go up, what happens to the temperature? It gets cooler. Okay? When you cool off a warm, wet cloud, it's going to drop precipitation. It's going to reach its dew point and drop precipitation. So basically, it has to go over the mountain, and to do that, it's got to cool off, and when it cools off, it rains. By the time it gets to the other side then, okay, it's lost most of its moisture, and we're going to have a dry side of a mountain. A lot of times, on one side of the mountain is desert-like area. If this is the Rocky Mountains, okay, overall, western South Dakota is pretty dry, okay, like Rapid City and the hills, okay, it doesn't get nearly as much precipitation as we do on this side of the state, okay, because the mountains are pretty close. Most of the clouds that they get, most of the air that they get is dry because it had to go over the mountains to get there. So hopefully that makes sense. And we'll call that good.